Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem sort zeros, ones and twos, which is an easy level problem. And trust me guys, I have come across this question many number of times. Even when I was starting my coding journey, this was the most frequent question that I used to come across. So it will be a fun solving this problem again. So let's read the problem description. The problem says given an array ARR containing zeros, ones and twos. Now sort the array in ascending order. So it's a very straightforward description, right? That in an array we have only zeros, ones and twos. We need to sort the array in ascending order. For example, in input 1, the array is 012 012 and the output is 001122. Simple, because we have sorted the array. And similarly, in example 2, for this array, if we sort, we'll first find all zeros, then ones and twos. Okay. So the problem examples are clear, problem description is clear, right? And the constraints are array size ranges from 1 to 10 to the power of 6. And array of I have only 3 elements, right? That is 0, 1 and 2. That's why it range between 0 to 2. So keeping this constraint in mind, one simple thing that we can do is simply use the inbuilt to sort function that we have in any programming language, right? As far as I am comfortable with C++, we have sort function in that, right? So with that sort function, if we pass the array that has given in our problem, we can simply sort our array and return the result. So it's a one-liner solution and it will definitely pass the test cases. But can we optimize our solution less than O of n log n? Which is straightforward to O of n. So can we optimize it to O of n? Let's see that. So if we compare our input array with our output array, do we find any sequence here? Yes. If we see properly, all the zeros in the input array have been placed in the starting position and all the twos in the last position and all the ones in the middle position. Simple. So what is the main observation here? We need to place all the zeros in the start and all the twos in the end. So by doing this, don't you think all the ones will be placed in the middle? Simple, right? I repeat it once again. If you simply place all the zeros in the starting position and all the twos in the ending position, don't you think all the ones will be automatically placed in the middle? Because we only have three numbers 0, 1, and 2. So if we place this 0 in the start, this 2 in the end, automatically all ones will be brought in the middle, right? So this is the main observation, right? Now let's dry run this example. I'll clear this output. Okay. So we need to keep the track of zeros and twos, right? So that we can place all the zeros in the start and all the twos in the end. Okay. How can we do that? We need to simply point them, right? So I'll create a pointer, 0 pointer in the starting position and twos pointer in the end position. First, we need to bring all the zeros in the start and all the twos in the end. Okay. Now to make both of this pointer compare and move, there should be one extra pointer, right? With which the values can be compared and the positions can be swapped, right? So I'll take extra pointer, which will be starting from start. Now let's see the magic, how it begins. Now let's start the execution. But before starting the execution, let's name this pointer as zeros pointer and this pointer as twos pointer, right? Because the name is pretty self-explanatory. So the execution starts. Now this pointer will check what is the element. It's 0, right? So it will swap its position element with zeros pointer position element. But since both are in same position, so both will move. Now this pointer will move one step ahead and this pointer will move one step ahead, right? Now moving this pointer makes sense because it will keep search of next element. But why did we move this pointer? Because we already found 0 here. So the next position where 0 can be placed is this. Okay. Now this pointer will check what is this element. It's 1, right? So it's neither 0 nor 2. So we need to simply move this pointer one step ahead. Okay. Again we'll check this element is 1. So we'll again move our pointer by one step. Okay. Now at this position the element is 0. So what we need to do? We need to bring this 0 to the correct position. And what is the correct position? The correct position is held by this zeros pointer, right? So we need to swap this element and this element. So we'll swap this. So this will become 0 and this will become 1. Simple. Now after we did the execution, we'll again move this pointer one step ahead. Okay. Now we see that here this is 1. Okay. So we'll move this pointer one step ahead. Okay. Now what is the element? Here the element is 2. So what we need to do? We need to swap this element's position with this element's position. Okay. So here we'll get 1 and here we'll get 2. Okay. Now after swapping the element, we need to bring this pointer one step behind, right? So this pointer will be pointing to this position, and similarly, we'll move this pointer one step ahead. Okay. Again, the element is 1. So ignore it and move it one step ahead. Now the element is 2. Okay. So we'll swap this position and this position. So here it will be 0 and here it will be 2. Okay. Now again, this pointer will move one step ahead. But now, do you guys think moving this pointer one step ahead will do any blunder? Let's see. If we move this pointer one step ahead, but if you see carefully, we did a blunder, right? We had a 0 here, which should have been placed here. Sorry, I forgot to move this pointer here. Yeah. So here there should have been 0 and here there should have been 1. But we skipped this 0. Why? Because we were simultaneously moving the 2's pointer and the 0's pointer, right? So whenever we are swapping our current element with the 2's element, right, we just need to move our 2's pointer, not this pointer. Because if we recap and see, we had 2 here and 0 here. So what did we do? We simply swap their positions, right? So here it was 0 and here it was 2, right? So after that, moving this position makes sense because here there will be all 2's, but we blindly move this pointer to the next step. We didn't even see whether this element is 0 or not. If it is 1, then well and good. But if it is 0, this element's correct position is at the leftmost position, right? So while swapping the element 2, we just need to move the 2's pointer, not the current pointer, because in the current pointer there could be element 0 which should have been placed here, right? So let the pointer be there only. Okay. And again this pointer has gone back. So yeah, now we moved our 2's pointer, right? Now this pointer is here only. Okay. So what we need to do? Now we need to check what is the element at this pointer. It's 0, right? So we'll swap this element with this element. Simple. So it will become 1 and it will become 0. Simple. So this was the main important point. How to move these pointers, right? Because when we were swapping zeros and 1, we were moving both zeros and 1's pointer. But when we swap 1's pointer and 2's pointer, right, we just need to bring this 2 pointer backside, that is decrement its position. But the 1's pointer position should be there itself. Okay. Now here we have 0, right? So we'll move this pointer to one step ahead. Again, since we swap this position with 1, we'll move this pointer again to one step ahead. Okay. Now we'll see what is the element here. Again, it's 0 here, right? So we need to swap this element with this element. So let's swap it. So here it will be 0 and here it will be 1. Simple. After swapping, we'll move our pointer one step ahead. Now here, both of these pointers are facing to each other, right? But the element is 0. Technically, the element should have been 2 because it is waiting for 2, right? But we have 0. So what we need to do? We need to swap this 0 with this element. Sorry, again I have missed this pointer, right? So this pointer will be here. So again, we need to swap this element with this element. Okay. So here it will be 0 and here it will be 1. Simple. Now after we swap this pointer will go here. Okay. Now when this pointer got here, what does it signify? Behind this pointer, there are all 2's. This was a valid position, I agree. But behind this, there were actual 2 values, right? This was the waiting place for 2. But behind this, there were already 2's, right? So we need to cross check whether our 1's pointer didn't overcome our 2's pointer. Okay. So after we execute our whole loop, right, we see that all the zeros have been placed in the start, all the 2's have been placed in the end. So when we placed our zeros and 2's in the start and end, automatically our 1's got placed in the middle. Simple. So with this, we have learned how we can effectively use 3 pointers, right? So generally, we'll use 2 pointers approach very much, right? But here we have seen the use case of how 3 pointers can be so much effective. And also with 3 pointers, how to move them, when to move 2 pointers when to move 2 pointers simultaneously, when to move only one pointer and not move the other pointer, and how it can impact to the other pointer. Computing this all things will get with practice, right? So we need to get out of our comfort zone and we need to try these different things, right? Because this problem could have been solved with just a sort function also, but we came out of our comfort zone and we did something with the 3 pointers which is very trivial, and let's assume the time constant is 10 to the power of 8. So with sorting also we couldn't have done that. So what is the approach they expect? They expect this approach, right? I know this is not intuitive, it's not at all intuitive. I myself said I have come across this problem multiple number of times, and there are certain problems which doesn't come from intuition, it just come from the practice that we do daily, right? So if they ask this approach, right, this problem from easy can directly go to medium level problem. Okay. So now, since we understood the approach, let's understand the code for this. So here's the code in C++. Although the logic is same irrespective of programming languages. Okay. So the function name is sort012, and here the array is passed by reference. That means we need to make changes to this array itself. So firstly, I have taken array size and stored it in n variable. Okay. After that, I have created 3 variables: zeros pointer, ones pointer, and twos pointer. You know very well about zeros pointer and twos pointer, right? But this ones pointer is this green pointer that we were moving with each step, right? So here we are running a loop while ones pointer is less than or equals to twos pointer, because when ones pointer go beyond twos pointer, then it is entering the region of the numbers which are only two, right? So we need to stop that loop there. So that's why still ones pointer is less than or equals to twos pointer. What we need to do? First, we are checking whether at ones pointer we have 0. If 0, then we are swapping array of zeros pointer with array of one pointer. Okay. And we are incrementing both of the pointers that we have seen in the diagram. But if arrays of ones pointer is equals to 1, then what we need to do? We just need to move the pointer one step ahead that we did, right? But if it is neither 0 nor 1, then it should be definitely 2, right? So at 2's position, what we did? We swapped arrays of 1's pointer and arrays of 2's pointer. But we only decremented 2's pointer because from the 2's pointer position, there could be a 0 that is coming at the 1's pointer position. Now, this 0 should be swapped with if exists, right? So that's why we have just decremented the 2's pointer and didn't increment the 1's pointer. Okay. So when this whole loop gets executed, our array will be sorted beautifully. So this was the solution with 3 pointer approach. Okay. Now what will be the time complexity for this approach? Here we are just running a loop while one's pointer is less than 2 pointer, where it could be at worst go till nth position. Okay. So the time complexity will be O of n. And what will be the space complexity? Here, instead of using these 3 pointer variables, we didn't use any extra space, right? So the space complexity will be O of 1. Now, if you look at the time complexity in the brute force, what we were doing, we were just using the inbuilt sort function, which takes n log n time complexity. But we trimmed it down to O of n, right? Which is very much efficient. So always start with brute force approach, but if you find any scope of improving or optimizing the solution, don't hesitate to jump into it. Get out of your comfort zone and try to understand it. When I Because when I started, even it was very trivial for me to understand about this pointers concept. But I failed multiple times, but I tried. So with because of that, the problem that I've solved 2 years back, I can still remember it because I have understood the concept. So I want you guys to do the same. Try to solve similar kind of problems where we have n number of pointers. Okay. I don't think we use n number of pointers, but at least if you try to find similar kind of problem, right? Try to solve it. It will come very handy in your next problems. So this was the video, guys. I hope you guys like this video. If you guys really did, then please like, share, and subscribe to my channel. It will really motivate me to bring more such content. If you guys have any queries or doubts, please comment it down. I'll try to respond to it as quickly as possible. And if you guys have any feedback for my teaching, please comment it down too so that I can improve on that. So see you guys tomorrow solving any other code problem. Till then, stay safe, stay happy, and peace.